Hey guys, welcome back to my channel. In today's video, we are going to discuss today's lead code problem of the day. So the question is largest positive integer that exits with its negative, right? So given an integer array nums that does not contain any zero, find the largest positive integer k such that minus k also exits in the array, right? So return the positive integer k. If there is no such integer, return -1. So the question is simple. We have to find that k whose negative is also present in the array, but that k should be maximum, right? So let's have a look at the example, right? So here these all are the elements. We have to find those positive integers whose negative also exits in the same array, right? So here 2 is there, -2. Is there any -2? No, there is no. So 2 cannot be the answer. 3 is there. Is there any -3? Yes, -3 is there. So -3 is the only integer that has its negative in the array. So 3 will be the answer. So similarly here 10 is there, but -10 is not there. 6 is there, -6 is not there. 7 is there, -7 is there, and then 1 is there, -1 is there. But the maximum is 7, right? The maximum is 7 that has its negative value. So 7 will be the answer. See, both 1 and 7 have their corresponding negative values in the array, but 7 has the higher value, right? So similarly, let's have a look at this example. -10, 8 have negative elements? No. So 6 have negative elements? No. 7, -7 is there? No. -2, -3, right? That means we couldn't find any element that has its negative in the same array. So we will simply return -1, right? So the question is very simple. So let's have a discussion on the approaches, right? So the first approach is the most brute force way that comes to my mind is we just have to find pair, right? One element will be here and the other element will be here, but one should be negative and one should be positive and they should be same, right? What I'm trying to say, if this is -2, this should be 2, right? So I can say 2 is a possible answer, right? So if I found something like 3 and -3, 3 is a possible answer. So we are going to check for all the pairs that is possible. So how we are going to check? We will keep two pointers I and j. Let's say I is here, so j will be from this index till the ending index, and we will be checking if I and j is forming a pair or not, right? Then after that I will get incremented, then we will check for j, right? So like that I will go from 0 till n-2 and j will go from I plus 1 till n-1, and then we will check for this condition, right? So how we are going to check? We will keep two if conditions. So the first one is if ARR of I, that means the first value. If the first value is negative, we will check for the ARR of j. If it is negative of first value or not. What is negative of negative? It will be positive. So let's say ARR of I is -2, right? So negative of negative will be 2, right? So we will simply check if 2 is equals to ARR of j or not, right? Basically, we will check if ARR of j is equals to 2 or not. If it is, that means we got -2 and 2, right? So it's a possible answer. So we will store the maximum answer, right? So here I'm going to store 2, right? So similarly, let's say ARR of j is negative, right? So we will do the same thing. We will convert it into positive and we will check for the ith index whether that number is the positive of this negative number or not. If it is, we will store the maximum answer, right? So let's have a look at the code. Code is also pretty simple. The same thing which I have just told you. I will go from 0 till n-2 and j will go from I plus 1 till n-1, and then we will check for these two conditions individually and we will store the maximum, right? Maximum of previous answer and the current answer. Here I am taking AR of j, right? So I am considering this is the negative element and negative of that element which is positive is equals to ARR of j. That means here ARR of I is negative and ARR of j is positive, right? So I'm storing maximum of answer comma ARR of j, right? Here similarly I'm storing answer comma ARR of I. At the end I'm going to return the answer, right? If I couldn't get any pair, I will be returning -1, right? So that's the brute force approach. Now let's have a look at the hash set approach, right? In this, what I'm going to do, I'm going to iterate through this array and I'm going to check whether its opposite element is present or not. Basically, we have visited the opposite element or not. What I'm trying to say, let's have a dry run on this example. So first I saw -1. What is the opposite of -1? It will be +1, right? Then I will check in the set whether +1 is there. I'm saying it's not there. So bro, don't do anything, move forward. But before moving forward, I will store this number in the set. So -1 will be in the set. Then I am at -2. So -2 has opposite +2, right? So I'm going to check, bro, +2 is there in the set or not? See, what we are trying to do, we are trying to check for the opposite element, that whether it was there before us or not, right? So similarly, it will check for +2 and +2 is not there. So move forward and put this in the set. So -2 is placed in the set. Now -3 came. -3 has opposite +3. So we will check +3 is visited or not. +3 was there or not. No, it was not there. How we got to know? We will check in the set. It was not there. So move forward and before that put this inside the set. So -3 will come here, right? So here 3 came. 3 has opposite -3. We will check whether -3 is in the set or not. Yes, -3 is there in the set, right? Because -3 we have already visited. So simply we will return the absolute value of this element, right? So we are not going to return, it's a possible answer. So at first answer will be -1 we are keeping, and then if we get a possible answer, I'm just storing something like answer equals to max of answer and absolute of this element. Why I'm taking absolute of this element? See, I'm taking the opposite value, right? So it can be this, say this can be something like +3 and -3 also, right? So in this case +3 will be here, so -3 is negative, so I will take the positive value. So here absolute of element is a possible answer, so I'm taking the maximum of those elements, right? So let's have a look at the code. I'm maintaining a unordered set, and then answer is -1 at first, then I'm going to iterate, right, from 0 to n-1, and here I'm going to check whether opposite of the element that I got, basically element is ELE, so opposite is -ELE, right? So if it is there in the set or not, right, this dot contain tells whether -nums of I is there in the set or not, right? If it is there, store the maximum of answer and absolute of this number. Then before going to the next iteration, I will insert this value. Right? Then at the end, I will simply return the answer. So that's how we are solving it using time complexity of n. We are iterating only n times, right? But we are taking a space of n, which is because of set that we have used here. So I forgot to tell you the time complexity of the previous one. It will be of n square and space complexity of 1. Why? Because why n square? Because we are iterating for I. Inside that we are iterating for j also, right? This will go for O of n time. This will also go for O of n time at the worst case. Not exactly, but I can consider this as O of n, right? So n into n will give n square. And this solution has time complexity of n and space complexity of n. And now I'm asking, can we optimize this more? We can. So in this approach, we are going to use a visited array, right? So it's a different approach. So let's have a look at the constraints that is given. So it is basically from -1000 till 1000, right? So what I'm going to do, I'm going to consider these values as the indices. Then in that particular index, I'm going to mark 0 or 1, right? Basically visited or not visited. But we have a problem here. What is that problem? That -1000 is also there, right? From -1000 till 1000, the values will be between them. So we cannot take the indices of negative value, right? So this is not possible. So we have to modify this somehow so that we can store negative and positive elements also, right? So what I'm going to do, I'm going to create an array of 2000 size, basically from 0 till 2000, right? So the size will be 2001. What I'm going to do, I'm going to store negative and positive elements in this array. But the question is how to store these elements, right? How to store those elements. So let's say element is -2 now. So the index will be element plus 1000, right? I'm considering its index to be element plus 1000. So in this case, -2 plus 1000, it will be giving 998, right? So I'm going to this index and I'm going to mark it as visited. But before doing that, I will check for the 2, right? Whether +2 is visited or not. So how to find the opposite index? Simple. So we have taken element, so take minus element. So minus element, that is 2, right? Minus of -2 is basically 2, right? So 2 plus 1000, it will be giving 1002. So we will go and check whether 1002 is visited or not. But we found that it is not visited. So don't do anything. Just mark this -2 as visited and then go for the next element, right? So let's say at some point of time I got the element 2, right? So the index will be 2 plus 1000. It will be 1002, which is somewhere here, right? So 1002 is somewhere here. Let's say the boundary is here, that is 1000, right? So see, so notice one thing. If it is -2, we will go 2 times left side. If it is +2, we will go 2 times to the right side. So that's how we are segregating negative and positive elements, right? So the index of 2 is 1002, but we will check for the -2 whether it is visited or not, right? So opposite index is basically minus of 2 plus 1000, that is 998. And we found that it is already visited. How? We visited in this ARR of I, that means basically element that we got, right? This one, absolute of element can be an answer. Let's have a dry run. After this you will be crystal clear with the approach, right? So let's say I'm iterating and I got element as -1. So find the opposite element. Basically, let's say this is the array from 0 till 2000 and I got -1, right? So get the opposite value. Opposite value is 1. Basically minus of -1 is 1. And get the index in this visited array. It will be element plus 1000, right? So opposite element is 1 plus 1000. We will check whether this 1001 is visited or not, right? So at first everything will be 0, that is not visited. So we found that, bro, this is 0, so it is not visited. So we won't do anything. We will mark -1 as visited. So how to mark -1 as visited? So go to the -1 index. How to go? Element plus 1000. So -1 plus 1000, it will be 999. So 999 will be marked as visited, that is 1, right? 999 will be marked as 1. Now I will check for 2. So opposite of 2 is -2, right? So go to the index and check whether -2 is visited or not. So index is -2 plus 1000, it will be 998. So 998, it will come somewhere here. It is 0, right? So it is not visited, so it's not a potential answer. So I will go to 2 and then say, bro, it is visited. So how I will go to 2? 2 plus 1000, right? 2 plus 1000 will give the index, that is 1002. So 1002 will be marked as visited. And now I will go ahead. -3 came. So -3, what is the opposite element of -3? That is 3, right? Go to visited array and check whether 3 is visited or not. How to check? 3 plus 1000, it will give 1003. We will check for this, but this is not visited, right? 1003 is not visited. So we will simply go and mark -3 as visited. -3 is basically -3 plus 1000. It will give 997. So 997 will be marked as visited. Then I will go to 3 and get the opposite of 3. What is the opposite of 3? It is minus 3. Then I will go to visited array and check whether minus 3 is visited or not. What is minus 3? Minus 3 plus 1000, right? So the index is 997 and I will check, bro, 997. Oh, 997 is visited. See, we have already visited this, right? So 997 is visited. So we will say this element, that is absolute of this element, is a possible answer. So we will store the maximum of answer and this element, right? So let's have a look at the code. Here I am creating the visited array of size 2001 and placing all those indices with 0. So why 2001? From 0 till 2000. So total number of indices will be 2001, right? So answer is initialized with -1 and then we are going to check the current index and opposite index, right? So the current index is nums of 5 plus 1000, opposite index is minus of nums of 5 plus 1000. So first I will go and check whether the opposite value is visited or not. If it is visited, that means we are at the current index and the opposite of that index is visited. So I will store the maximum of answer and absolute of this element, right? So before finishing, I will say, bro, this current index, no, this is visited. So visited of current index will be 1 and then I will go for the next iteration, right? So at the end I will be returning the answer, and if this block never got executed, answer will be having -1. That's the reason we initialized with -1. So here the time complexity is of n. Why? Because this is running for of n times and space complexity is of 2001. So it's a constant space, so I can say it's a of one space, right? So that's it for the video. If you like the video, hit the like button, subscribe to my channel. Until next time, see ya.